Here we're going to look at a couple of calculations making an acidic buffer, and we're making them by partly neutralising a weak acid. So the weak acid will be in excess and we're adding a portion of strong alkali. This will create a solution where we've got both some weak acid and its salt. I'll show this in the equation here. So there's our weak acid, and if we add some sodium hydroxide, then we'll make the salt of the acid. And for it to be an acidic buffer, we want significant portions of those two things, which means that the weak acid needs to be in excess. So in the first example here, if we have a look at the equation and then work out the moles for the ethanoic acid and sodium hydroxide, like so. When these have reacted, we need to work out how much of the ethanoic acid is left, and we need to simply subtract the moles of sodium hydroxide from the moles of ethanoic acid, and this will give us the moles of ethanoic acid remaining. We also need to work out the moles of sodium ethanoate that we've made, and this will simply be however much of the sodium hydroxide we added, which was 2.5 times 10 to the minus 3. So I now know the moles of ethanoic acid and of sodium ethanoate that I have in the buffer. These are moles. Remember that they share the same volume, so I can just use the moles. If you want, you can work out the concentrations, but we'll be dividing them both by the same number, so I'm just going to leave mine as moles. I'll now rearrange my Ka expression to make the hydrogen ion concentration subject. Like so. And I'm sure we can see that since the moles or the concentration of the acid and the salt are the same, that they're just going to cancel, which means that my hydrogen ion concentration is 1.75 times 10 to the minus 5, and my pH is minus log of that, which gives me a pH of 4.76 to 2 decimal places. Let's have a go at the second example. Try writing the equation. So there's methanoic acid with potassium hydroxide, and we're making potassium methanoate as the salt. Let's have a look at the moles. So we've got 4 times 10 to the minus 3 moles of methanoic acid and 2.5 times 10 to the minus 3 moles of potassium hydroxide. Same as we did before. The moles of methanoic acid remaining is one take away the other, which should give us 1.5 times 10 to the minus 3. And for the moles of potassium methanoate, then this is however much potassium hydroxide we added, and that's going to be 2.5 times 10 to the minus 3. Let's pop those numbers into the rearranged Ka expression. Again, at the minute we just have the moles, but moles are fine since they've both got the same volume. So Ka of methanoic acid, 3.6 times 10 to the minus 4, and I'll multiply that by the moles of the acid, which is 1.5 times 10 to the minus 3, over the moles of the salt, 2.5 times 10 to the minus 3, and that should give us 2.16 times 10 to the minus 4, and so pH is minus log of the hydrogen ion concentration, and I'm getting 3.6.